We're going to talk a little more about factoring polynomials. And in particular, we want to look first at some patterns for polynomials. So we have a pattern that's called the perfect square trinomial. And the way that we're going to be able to recognize it is if our first term is a perfect square and the last term is a perfect square, um, then we have to identify what it is that's been squared in each case. So if the middle term is 2 times the thing that's been squared times the other thing that's been squared, then we can factor this pattern. And of course, I'm going to explain this with an example in just a second. When we have a plus in front of the 2ab, then it's going to factor as a plus b squared. If we got a minus in front of the 2ab, it's going to factor as a minus b squared. So the steps for this are determine whether the first and third terms are both perfect squares and have positive coefficients. And if this is the case, we identify a and b, and determine if the middle term equals 2ab or negative 2ab. Okay, that's what we're going to be looking at. Um, and again, pointed out that if we've got a plus in front of 2ab, then when we factor, we'll have plus b. If we've got a minus in front of 2ab, when we factor, it's going to be minus b. Okay, so let's take a look at perfect squares, just some perfect square numbers. Numbers on the bottom are what we call perfect squares because they are the square, what we get when we square the number that's above. For instance, when I square 3, I get 9. 9 is a perfect square. When I square 7, I get 49. So we say 49 is a perfect square. It's helpful to recognize these, as we go through. Because it may give you a hint that, hey, I can use one of these special patterns. So let's take a look. We've got u squared plus 10u plus 25. Our leading coefficient is 1. We could use some other strategy, but if we can recognize this perfect square pattern, then it's going to save us a lot of trouble. So what I see is that my first term, u squared is a perfect square because we've taken u, we've squared it. And I recognize 25 as a perfect square. It is 5 squared. So, we want to think about it that way. This is something squared, and this is something squared. We need to know what the something is, okay? But we can't claim that this is a perfect square pattern until we know that the middle term is going to be 2 times whatever it is our A is times whatever our B is, okay? And so the question we need to ask, since our A is U and our B is 5, I want to know, does this middle term equal 2 times U times 5? And of course it does, right? 10U is the same thing as 2 times U times 5. It gives us 10U. So this does meet the pattern. I've got my A squared. I've got 2 times A times B. I've got B squared. Okay, just like we have here. And so what we know when we have this pattern is that it factors this way. Whatever A is plus whatever B is, all of that squared. So my A is U, my B is 5. This factors as U plus 5 squared. Now you might think that's a lot of steps, but these two steps really can happen in your head. Once we recognize, oh, this is a perfect square up front, I got a perfect square on the end. Is this 2 times U times 5? It is. So I go this last step and we're done. Okay. So that's how we apply the perfect square trinomial pattern. Here's another example. Okay, we've got w squared plus 6w plus 9. Of course, w squared is a perfect square because we take w, we square it. 9 is a perfect square because it is 3 squared. So I want to ask myself, is 6w 2 times w times 3, right? That's what I need my middle term to be. And of course it is. And so we can say this is just going to be equal to w plus 3 squared. All right. So again, these two lines are my thoughts, but everything else, just write down. You recognize the pattern and you can factor. Okay, let's try it. But this time, notice that the sign on our middle term is negative. So I notice, first of all, I got a perfect square up here. I've highlighted the minus sign in red just so that we make sure we handle that correctly. And then, of course, 36, I know that that's a perfect square. So I need to know, is my middle term 2 times t times 6? Okay, that's what I need it to be. I forgot to change that part. But yeah, is it 2 times t times 6? And it is. 2 times t times 6 is 12t. So it fits the pattern. Our rule this time, though, is that it's going to be a minus b. Since I've got the minus right here, it's going to be a minus b. So when I factor this, we get t minus 6 squared. Okay, so what if the leading coefficient is not 1? Because in all the examples that we looked at so far, the leading coefficient has been 1. If it's not 1, well, if it's a perfect square, it still works, right? So I recognize that 49u squared is a perfect square. It's 7u squared, right? And 4 is a perfect square. It's just 2 squared. So we've identified, our A and our B, right? 49u squared is 7u squared. 4 is 2 squared. So I need to ask myself, is 28u 2 times my A times my B? And it is, right? 28u is equal to 2 times 7u times 2, right? So this fits the pattern, okay? Fits the pattern 2 times A times B in the middle. And so we're going to factor this as A minus B. Our A is 7u, our B is 2. So this is going to be 7 minus 2 squared. So it works, even if our coefficient is greater than 1. Now, could we have done some of our other factoring methods like A times C? You could do that, but notice that when we multiply A times C in this case, we're going to end up with what? About 196, I think. That's a lot to have to factor, try to figure out which two numbers are going to add up to negative 28. So if you can recognize that this is a perfect square pattern, then we can apply that. So the key is, recognizing first that the leading term is a perfect square, and the constant is a perfect square, or the last term is a perfect square. And so then that leads me to do the check. Does the middle term fit the pattern? If it does, then we can factor this much more quickly, recognizing the pattern, than trying to do A times C. Right, so there's another factoring pattern that's really important. This one is called the difference of squares. And so basically the pattern is A squared minus B squared. So I'm looking to have a perfect first term, perfect square first term, perfect square second term, and I'm taking the difference. I'm subtracting. Okay. If that's what I have, we just got these two terms. If that's what I have, factors as A plus B times a minus b. So we should point out the pattern is for subtraction. If we have a sum, then it doesn't work. Okay, it does not apply if we have a squared plus b squared. It has to be a squared minus b squared. So let's take a look. Okay, we got 16 minus 25y squared. I see perfect squares everywhere here. I've got a difference, right? So 16 is 4 squared. 25y squared is 5y squared. So I've got my perfect squares. Okay, my pattern again is a squared minus b squared. It's going to factor as a minus b times a plus b. And so we get 4 minus 5y times 4 plus 5y. Okay. And it doesn't matter which order you put these in. We could have said 4 plus 5y times 4 minus 5y. Same thing. Okay, but it does fit the pattern. Okay, we had a perfect square as our first term, perfect square as our second term. We're taking the difference. Okay, I've got that highlighted, that this is for the difference. It doesn't apply if we have a sum. Okay, and so it factors as 4 minus 5y times 4 plus 5y. All right, here's another. We got 49x squared minus 64y squared. Again, I see perfect squares. Okay, 49x squared is 7x squared. 64y squared is 8y squared. Okay, so we've got the difference. We know what our a and b are. And so we can just factor this as 7x minus 8y times 7x plus 8y. And with this one, we got 25v squared. That's a perfect square. 9, that's a perfect square. But in this case, it's plus, right? So I got that highlighted, and really, there's nothing I can do with it. I mean, yeah, these are perfect squares, but because of that plus, there's nothing I can do with this. So this one is just prime. It has to be minus in order for us to apply the pattern for differences of squares. Okay, so just a couple of other things as far as factoring. First of all, again, first step is always factor out the greatest common factor. It's going to make your life easier if you do that. And so when I look at these three terms, I notice that I do have a common factor. I believe I can factor out 3u for each one. So we factor out 3u. 3u times 2u squared gives me 6u cubed. 3u times negative 11u gives me negative 33u squared. 3u times negative 6 is negative 18u. Okay. And so now I'm at a point where I'm going to use my AC method. All right. I want to get a sum of negative 11u. I'm going to look at 2 times negative 6. That gives me negative 12. So the factors of negative 12 that add up to negative 11 are going to be negative 12 and 1. Right? Negative 12 times 1 gives me negative 12. Negative 12 plus 1 gives me negative 11. So I can rewrite negative 11u as minus 12u plus 1u. Okay. So of course now we're going to do our grouping. I group the first two terms. I group the last two terms. I look at the first two terms to see what they have in common. They have 2u in common. I factored that out. And I'm left with u minus 6. Here, we don't have anything in common, but that's okay because it's already u minus 6. However, I did put the 1 out front, or a 1 out front, just to hold its place when we get ready to factor. So now for these two, they have in common u minus 6 We're going to be left with 2u plus 1. All right, here's another one, very similar to the one we just did. Again, looking through, even though this is a trinomial, notice that I've got a greatest common factor, or common factor. I want to take out the greatest common factor, and that's going to be 4w. I'm taking out 4w, and that leaves me with 3w squared minus 10w plus 7. Okay, that's a little better to deal with. So now we can use our AC method, and I'm looking at 3 times 7 gives me 21. So I need the factors of 21 that add up to negative 10. And so those factors are going to be negative 7 and negative 3. Negative 7 times negative 3 gives me 21. Negative 7 plus negative 3 gives me negative 10. So we got 3w squared minus 7w minus 3w plus 7. The minus 7w minus 3w come in from the factors that we identified that work. Okay, so rewrote negative 10w this way. Now, and it doesn't matter, both of them are negative. You could have put minus 3w minus 7w. That's fine. I think we'll get there either way. Okay, but we're going to do our grouping. Of course, we want to be careful here. Since we're putting a parentheses here, we've got to factor out that minus from everything that follows that parenthesis. So we had a negative 3w. Now this is positive. We had a positive 7. Now that's going to be negative. Okay, we got that. And for our first two, when we group them, they do have a w in common. Okay. All right, but the 3w and the negative 7, they don't have anything in common, so we just put a 1 there to hold its place. Now we see we've got 3w minus 7 in common. I can factor that out. We're left with w minus 1. All right, so that's it for factoring. Hopefully that'll help you get through a few more problems. Don't forget to look at those patterns because they can save you some time. And with the difference of square pattern, you might need to use it twice. So just think about that. And yeah, we'll talk to you later. Bye.